In this chapter, we are going to discuss about NMR yield, that is how yield is calculated, that is reaction yield is calculated by analyzing the NMR spectra. So before moving to this chapter, first I want to explain the term integral that we generally use in NMR spectra. In NMR spectra, the term integral refers to the number of protons which has the same chemical shift value. It will be more clear if we take an example. So let's take an example of ethanol, that is CH3CH2OH. If we analyze its NMR spectra, then we found here three types of proton. One is OH proton, one is CH2 proton, and another one is CH3 proton. These three protons resonates at a different frequency. So we got a triplet at a chemical shift value 1.18, that is due to the CH3 proton, and a quartet due to CH2 proton at 3.59 as shown in the figure. And the OH proton generally comes around 4.7. Here we can ignore it. Now, after recording the NMR spectra, if we integrate this proton, that is the quartet that arrives at 3.59, if we integrate this and set the value to 2, that is for 2 proton, and set the value to 2, and then we integrate this proton, CH3 proton, then it will automatically give the value 3, that is number of protons 3. That means integration gives the number of protons associated with that particular chemical shift value. But if we have two different types of molecules, let's say a molecule like this, trimethoxybenzene, and ethanol. Here, if we integrate, here this is a mixture of two molecules and we take its NMR, and the NMR data will shown in this picture, that is the CH3 proton. All the CH3 proton of this compound comes at 3.81, and this is a singlet. That is here the 9 proton gives one chemical shift value at 3.81, and if we integrate it first, then and the remaining 3 protons, that is the aromatic protons, which are also identical, they give a singlet at 6.07 ppm. Now we have two different molecules in my sample, and here one is this and one is this, and if here I integrate the CH2 proton first, and of ethanol and assign the value to 2, and then I integrate the CH3 proton that comes at 3.59, then automatically it will give the value of 3.0. But if after integrating the 2, if I integrate the protons, that comes at 3.89, that is the 9H proton, then I may not get the value of 9, which is expected to be. Why? Because these protons are in a different molecule. Similarly, if we first integrate these 9 protons and assign the value 9, and then we integrate the protons of the aromatics region, that is at 6.07, then we get exactly 3 protons, because there are 3 number of protons. But now if we try to integrate this CH2 or this CH3, then we may not get the integral value of 2 or 3 respectively. So integration only holds good for the same molecule. If molecule is different, if we have mixture of molecule, then the integration does not give the exact ratio, because we may have the different concentration of hydrogen atoms. So as far we came to know, the integral gives the value of number of identical protons. Now we will see how we determine the chemical reaction yield by using this integral.